Hello, this is Mr. Bradsby. We're going to work some more on multiplication. Uh, we've been kind of looking at different ways of doing the multiplication problems. And today I'm going to categorize those for you. And we're going to model those. The first way that we were looking at doing our multiplication is called the area model. Now the area model deals with the area of rectangles. And as we pointed out and made the squares, it's the number of square units in a rectangle. So the area model deals with the area of a rectangle. So as an example, we have the problem 35 times 9. Okay, 35 times 9. So it would be 9 here and 35 here. But with the area, we do it 35 as 30 plus 5. Okay? Now, this is also called the place value model. Area model or place value, because we do the place value here. The 10's place is 30, the 1's place is 5. So we're doing them as a place value also, showing the place value, 30 plus 5. So 9 times 30 plus 5, we do that by showing the area is 9 times 30 and 9 times the 5. Okay? Then we go over here and write down the answers. 9 times 30 is 9 times 3 is 27 tens, because it's got 30. So that's 270, and this is 9 times 5 is 45. So we do the place value over here. It's got 270 tens, 27 tens, and 45 ones. We add them, 5, 11, 315. So this is a model of the area, okay? The area model, or it's called the place value model. So that's one way of doing our multiplication. We use the rectangle, find the area. The area here is 270 square units. The area here is 45 square units. Add them together, you get 315 square units. But we've dropped that square units off because we're really just practicing to do the multiplication. Another model, which we've used quite a bit, is called the expanded notation model. Expanded notation model. Okay? This is where we take and give the expanded notation for 41. That's 40 plus 1. That's expanded out. We know that 40 plus 1 is 41 times the 4. Okay? The expanded notation. So we expand that out, and then we do the multiplication. 4 times 40. 4 times 4 is 16. And again, times 10, because it's 40. And 4 times 1 is 4. The answer, 164. So that's the one we've been using a lot, the expanded notation model. Another example would be like 74 times 6. Expand out the 74, okay? 70 plus 4. And you don't have to do any modeling for this. You could if you want, but it looks exactly like that. 70 plus 4 times 6. So the area here would, if you put it into the area, it would be the 70 here, right? And the 4 here, and you'd get the same thing. 6 times 70. 7 times 6 is 42 tens. 6 times 4 is 24. We add them together. 4, 4, 4. Okay? So there's an example of the expanded notation model. The next model is new. It's called the distributive property, and maybe you've seen or heard of it before, but let me give you an example of the distributive property. Suppose we have 6 times 27. This is a horizontal method, not a vertical, although you could change the vertical into this if you had 27 times 6. Change it into this. But the distributive property we follow very similar. It's 6 times 27. But again, we're going to expand that 20 plus 7. Now, the distributive property says if you've got 6 times 20 plus 7, that's the same as 6 times 20 plus 6 times 7. Looks a lot like what we've been doing, doesn't it? You expand it out, 20 plus 7, you multiply 6 times 20, 6 times 7. But it's just written out mathematically in this horizontal steps. So this turns out to be 6 times 20 is 120, plus 6 times 7 is 42. Add those together, 162. Okay? It's called the distributive property. You just distribute the 6 times the 20 and the 6 times the 7. It's not all multiplication, is it? A way of writing it in algebraic form is any number times the sum of two numbers, b plus c, is a times b plus a times c. Let's do one more example of the distributive property. Suppose we had a problem like 5 times 55. How's that? Okay, 5 times 55. Distribute them 5 times 50 plus 5. Okay, then distribute. You do 5 times 50 and 5 times 5. Plus 5 times 5. Okay? That's the distributive. 5 times 50, 5 times 5. So 5 times 50, 5 times 5 is 25, but it's 50, so it's tens. 250 plus 5 times 5, 25. Add them together, you get 275. So there's another example of the distributive property. You just do it out horizontally and you multiply and add them up. So they're all very similar. My idea is to use the one you like the best. But sometimes people want to talk about the distributive property or expanded notation. Those are all nice things to know in mathematics. So I've got one more thing for you to do today. Okay, I've got the same problem here, 5 times 32. But I want you to put them and use the 3 different methods. The first one, use the area method, or it's the same, it's called the place value method. So do that here. Okay, then do the same problem in expanded notation. And then finally, do it using the distributive property. Put me on pause, work these problems the way it's indicated, and then we'll discuss them. So bring me back when you're finished. Okay, so you're finished. Well, the area model uses the area of a rectangle, and it's 32 times 5. And so we make that 30 plus 5, and then 5 times 30 here, and equals 5 times 5 here. So 5 times 30 is 15 tens, 150. 5 times 5 is 25. So we add them over here, 150 plus 25, 175. Oops, Larry, shame on you. We had 32, didn't we? So let's go back and redo that with a 2. Okay, 32. Okay, so it'll be 5 times 30, 5 times 2, which is 10. So instead of that, we got 150, and 10 is 160. Boy, shame on me. I'm sorry. It was 32. I thought it was 35. So it's 5 times 2, 10. So 150 and 10 is 160. Well, the expanded notation, it's 30 plus 2. That's the expanded notation multiplied by 5. And we get 30 times 5, 150. 5 times 2, 10. Answer, 160. Ah, good. Now the distributive property, distributed out, it's 5 times 30 plus 2 again. So distributed out, 5 times 30, 150. 5 times 2, 10. Add them, 160. Same answer again. So that's an example of each of those. Well, the teachers can answer any questions you might have over this lesson and probably have a little bit of practice on what these are about. But again, my idea is when you get in and you get to make your choice, use the one that you like the best. Which one makes more sense to you? Which one would be easier? Which one would be quicker? Good. I enjoyed the lesson. Enjoy your mathematics.